Pause the video now and make an attempt to solve this problem using recursion. Let's write a program to compute the remainder of dividing integers a and b without using modulo operator. If we divide an integer a by b, we get q as the answer with the remainder r. A is called the dividend, b is called the divisor, and q is called the quotient. For example, dividing 7 by 5 gives us 1 as the answer. With remainder 2. We can form an equation relating them. We can rearrange the equation to find the remainder. We can write a program that uses the formula to compute the remainder. We know r equals a minus bq, where a is the dividend, b is the divisor, and q is the quotient. Dividend and divisor are input parameters. Q is calculated using the input parameters. Time complexity is O of 1 and space complexity is O of 1. Let's manually compute the modulo value for dividend 16 and divisor 3. We have 3 variables. The initial values are 16 and 3. When we subtract 3 from 16, we get 13. And when we subtract 3 from 13, we get 10. 13 is the new value here of the dividend. Once we subtract 3 from 10, we get 7. We repeat this process until the quotient becomes less than divisor. In this case, quotient 1 is less than divisor value, which is 3. The value of the quotient is the result. Pause the video now and write a program that uses iteration to compute modulo. The method modulo takes 2 arguments, dividend and divisor. We need to return the remainder as the answer. This is the variable called quotient. Before we enter the loop, we need to initialize the quotient variable to 0. We can now enter the loop to do repeating work. We need to compute the value of quotient by subtracting divisor from dividend. We need to update the dividend value with quotient. We reduce the value of dividend. This moves us towards the terminating condition when quotient becomes smaller than divisor. Let's draw the recursion diagram for the problem. The input is 16 and 3. The result for this input is 1. We can reduce the problem to a smaller subproblem by subtracting 3 from 16. So we get 13. The result of the subproblem is 1. In the combine step, what do we need to do to the result of the subproblem to get the result for the original problem? We do nothing.
What would you do if you had $1 million?
Well, what about you now? What would you do?
Nothing.
Nothing, huh?
I would relax. I would sit on my ass all day. I would do nothing.
Well, you don't need $1 million to do nothing, man. Take a look at my cousin. He's broke, don't do shit.
What is the size of the problem? Size of the problem is number of subtractions required to reach the base case. What happens in the decomposition of problem step? We reduce the problem by subtracting divisor from dividend. What do we do in the combine step? We do nothing. The base case occurs when quotient is less than divisor. We return the quotient. In the recursive case, we subtract divisor from dividend. Stop the video now and write the code for recursive solution that computes the modulo. The interface for the modulo method is the same as the iterative solution. We then have a reduction step where we subtract divisor from dividend to initialize quotient. We reduce in this step. We then code the base case. In the recursive case, we pass in the reduced value of quotient as the dividend and make a recursive call. The divisor value is the same in all the recursive calls. Sign up for your free coding interview coaching call. Fuck. Sign up for your free coaching call by going to codinginterview.coach.